According to section 696.60 of the National Electrical Code, abbreviated NEC, a tap conductor from the fire pump service to the jockey pump is permitted if the tap conduit is encased in at least 2 inches of concrete. You can make the overcurrent protection, abbreviated OCP, large enough to handle the locked rotor currents without upsizing the wire. However, the following conditions must be met. Firstly, the OCP must be listed for the type of motor used. Secondly, the OCP must be selected according to the NEC requirements for the locked rotor current of the motor. Thirdly, the OCP must be properly sized to prevent damage to the motor in the event of a fault. If the size of the OCP is too large, it may not provide adequate protection for the motor in the event of a locked rotor condition. Therefore, it is important to carefully select the OCP size based on the motor's locked rotor current rating. It may be difficult to determine the locked rotor currents for the fire pump and jockey pump without consulting the manufacturer's data. However, you can make an informed decision by selecting an OCP size that is typically used for similar motors. Alternatively, consult with a qualified electrician or engineer for assistance. When dealing with electrical systems, particularly those related to life safety such as fire pumps, adherence to the National Electrical Code is paramount. The NEC provides specific guidelines to ensure the safety and reliability of these systems. Let's delve deeper into the specifics mentioned regarding fire pumps and jockey pumps. The allowance for a tap conductor from the fire pump service to the jockey pump, as per NEC section 696.6d, hinges on a critical safety measure: the encasement of the tap conduit in at least 2 inches of concrete. This requirement serves a vital purpose, providing a fire-resistant barrier that protects the conductors from heat and physical damage in the event of a fire. The concrete encasement ensures the integrity of the electrical connection, allowing the jockey pump to continue operating and maintaining water pressure in the fire sprinkler system even under fire conditions. This is crucial for the fire suppression system to function effectively. Now let's consider the overcurrent protection, the OCP, for the fire pump motor. The NEC mandates that the OCP be sized appropriately to handle the locked rotor currents of the motor. Locked rotor current refers to the high current drawn by the motor when it is initially started or stalled. Properly sizing the OCP is essential to prevent nuisance tripping during motor start-up while still providing adequate protection against overloads and short circuits. There's an allowance to size the OCP large enough to handle the locked rotor currents without necessarily upsizing the wire. However, this flexibility comes with specific stipulations. Firstly, the OCP must be listed for the specific type of motor being used. This listing ensures that the OCP is designed and tested to work correctly with the motor's characteristics, providing reliable protection. Secondly, the OCP selection must align with the NEC requirements for the motor's locked rotor current. The NEC provides tables and guidelines for determining the appropriate OCP size based on the motor's horsepower, voltage, and other factors. These requirements are in place to ensure that the OCP provides adequate protection without being overly sensitive. Thirdly, the OCP must be properly sized to prevent damage to the motor in the event of a fault, such as a short circuit or ground fault. The OCP should be capable of quickly interrupting the current flow to prevent overheating and potential damage to the motor windings. While it's permissible to size the OCP to accommodate the locked rotor currents, it's crucial to avoid oversizing it excessively. An OCP that is too large may not provide sufficient protection for the motor in a locked rotor condition. If the OCP rating is significantly higher than necessary, it may not trip quickly enough to prevent damage to the motor windings during a prolonged stall. Determining the precise locked rotor currents for the fire pump and jockey pump motors can be challenging without access to the manufacturer's data. Motor nameplate data will show the locked rotor amps, or the locked rotor kVA per horsepower. The locked rotor amps value should be used whenever possible. If the locked rotor current information is unavailable, one approach is to select an OCP size that is commonly used for similar motors with comparable horsepower and voltage ratings. Another option is to seek guidance from a qualified electrician or engineer who has experience with fire pump systems. These professionals can assess specific installation requirements and recommend an appropriate OCP size that meets the NEC guidelines and provides adequate protection for the motors. Remember, electrical systems, especially those critical for life safety, demand meticulous attention to detail and adherence to the NEC. This includes careful selection of components, proper installation techniques, and thorough testing to ensure reliable operation. The NEC serves as a comprehensive guide for ensuring the safety and functionality of electrical installations, and compliance with its provisions is essential for protecting people and property. In the context of fire pump and jockey pump systems, the NEC provides specific guidelines for tap conductors, overcurrent protection, and other critical aspects of the installation. By following these guidelines, electrical professionals can create systems that are both safe and effective in the event of a fire. Now let us discuss some additional important considerations for fire pump installations as they relate to the National Electrical Code. We will begin by discussing the concept of separation. Fire pumps are considered life safety equipment and, as such, are required to have a high degree of reliability. To ensure this reliability, the NEC mandates that the fire pump power source, wiring, and overcurrent protection be kept physically separate from other electrical systems in the building. This separation helps to prevent a fire or other electrical fault in the general building electrical system from impacting the operation of the fire pump. NEC Section 695.12 covers the requirements for the separation of circuits. This section requires that the supply conductors for the fire pump be installed in their own raceway system, separate from all other circuits. The raceway must be of a type approved for fire pump circuits, such as rigid metal conduit or electrical metallic tubing. The fire pump conductors must also be protected by overcurrent devices that are separate from the overcurrent devices protecting other circuits. This separation of overcurrent protection ensures that a fault on another circuit will not cause the fire pump to shut down. In addition to this separation of circuits, the NEC also requires that the fire pump controller be located in a separate room or enclosure from other electrical equipment. This separation helps to protect the controller from physical damage and from exposure to moisture or other contaminants. Now we will focus on the reliability of the power source. The NEC requires that fire pumps have a reliable source of power that is capable of providing the necessary voltage and current to operate the pump under all fire conditions. The most common source of power for a fire pump is the utility electrical current. However, in some cases, a generator may be required to provide backup power in the event of a utility power outage. NEC Section 695.3 covers the requirements for fire pump power sources. This section requires that the power source be capable of providing at least 100% of the pump's rated horsepower. The power source must also be capable of providing the necessary voltage and current to start and operate the pump under all fire conditions. If a generator is used as the power source, it must be sized to meet the requirements of NEC Section 700, which covers emergency power systems. The generator must also be equipped with an automatic transfer switch that will automatically transfer power to the fire pump in the event of a utility power outage. The automatic transfer switch must be listed for fire pump service and must be capable of transferring power within the time limit specified in NEC Section 695.7. We now discuss overcurrent protection in greater detail. Overcurrent protection is an essential part of any electrical system, but it is especially important for fire pump circuits. Overcurrent protection devices, such as fuses and circuit breakers, are designed to protect electrical equipment from damage caused by overloads and short circuits. NEC Section 695.5 covers the requirements for overcurrent protection of fire pump circuits. This section requires that the overcurrent devices be sized to protect a fire pump motor and the associated wiring from damage caused by overloads and short circuits. The overcurrent devices must also be of a type that is approved for fire pump service. In general, the overcurrent devices should be sized at 125% of the fire pump motor's full load current rating. This will provide adequate protection against overloads without causing nuisance tripping during motor startup. However, the overcurrent devices must not exceed the maximum size allowed by NEC section 430.52, which covers motor circuit protection. In some cases, it may be necessary to use a time delay fuse or a circuit breaker with an adjustable trip setting to prevent nuisance tripping during motor startup. The time delay fuse or circuit breaker will allow the motor to draw a high current for a short period of time without tripping, which is necessary to overcome the motor's inrush current. Motor controllers are another major component. The fire pump controller is the brain of the fire pump system. It is responsible for starting and stopping the pump, monitoring the system pressure, and providing alarm signals in the event of a problem. NEC section 695.6 covers the requirements for fire pump controllers. This section requires that the controller be listed for fire pump service and that it be installed in accordance with the manufacturer's instructions. The controller must also be equipped with a number of features, including an automatic start function, a manual start function, a pressure sensing device, and alarm contacts. The automatic start function will automatically start the pump when the system pressure drops below a certain level. The manual start function allows the pump to be started manually, even if the system pressure is normal. The pressure sensing device monitors the system pressure and provides a signal to the controller. The alarm contacts are used to send alarm signals to a remote monitoring station in the event of a problem, such as a low system pressure or a pump failure. And now let's discuss the pump wiring in greater detail. The wiring for fire pump circuits must be sized to carry the full load current of the fire pump motor, plus any additional loads that are connected to the circuit. The wiring must also be protected from physical damage and from exposure to moisture or other contaminants. NEC section 695.14 covers the requirements for fire pump wiring. This section requires that the wiring be installed in a raceway system, such as rigid metal conduit or electrical metallic tubing. The wiring must also be of a type that is approved for fire pump service, such as THHN or XHHW. The size of the wiring must be determined in accordance with NEC section 310.15, which covers conductor ampacity. The wiring must be sized to carry at least 125% of the fire pump motor's full load current rating. This will provide adequate capacity to handle the motor's inrush current during start-up and to prevent voltage drop during pump operation. The emergency power supply. As discussed, the NEC requires that fire pumps have a reliable source of power that is capable of providing the necessary voltage and current to operate the pump under all fire conditions. In many cases, the utility electrical grid is the primary source of power for the fire pump. However, in some cases, a generator may be required to provide backup power in the event of a utility power outage. NEC section 700 covers the requirements for emergency power system. This section requires that the emergency power system be capable of providing power to the fire pump within 10 seconds of a utility power outage. The emergency power system must also be capable of providing power to the fire pump for at least 2 hours. The generator must be sized to meet the requirements of NEC section 700 and must be equipped with an automatic transfer switch that will automatically transfer power to the fire pump in the event of a utility power outage. The automatic transfer switch must be listed for fire pump service and must be capable of transferring power within the time limits specified in NEC section 695.7. Now we will discuss specific code sections to consider. When designing and installing fire pump systems, it is important to be familiar with the relevant sections of the National Electrical Code. Some of the most important NEC sections to consider include 695, which covers fire pumps. This article provides detailed requirements for the installation, wiring, and protection of fire pump systems. Other sections to consider are 430, which covers motors and motor circuits. This article provides requirements for the protection of motors from overloads and short circuits. Also, 700 covers emergency systems. This article provides requirements for emergency power systems, which may be used to provide backup power to fire pumps. 310.15 covers conductor ampacity. This section provides requirements for determining the ampacity of conductors. Conductor ampacity is the maximum amount of current that a conductor can safely carry. NEC Table 310.15b16 is used to determine the allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius, not more than 3 current carrying conductors in raceway or cable or earth, based on ambient temperature of 30 degrees Celsius. The ampacities are listed for copper and aluminum conductors. If the ambient temperature is higher than 30 degrees Celsius, the ampacity of the conductor must be derated in accordance with the correction factors in NEC Table 310.15b2. If there are more than 3 current carrying conductors in a raceway or cable, the ampacity of the conductors must be derated in accordance with the adjustment factors in NEC Table 310.15c1. It is also important to consult with the local authorities having jurisdiction to determine if there are any additional requirements for fire pump systems in your area. By following the requirements of the NEC and consulting with the local authorities having jurisdiction, you can ensure that your fire pump system is safe, reliable, and compliant with all applicable codes and regulations. Let us summarize key points for fire pump and jockey pump electrical installations according to the NEC. Firstly, adhere to NEC 696.6D for tap conductors from the fire pump to the jockey pump, ensuring the conduit is encased in at least 2 inches of concrete for fire resistance. Secondly, size the overcurrent protection, the OC, according to NEC requirements for the motor's locked rotor current, allowing for adjustments to handle inrush current without oversizing the wire, provided the OCP is listed for the motor type. Thirdly, consider the specific requirements outlined in NEC 695 regarding the power source, wiring, overcurrent protection, and separation of fire pump circuits from other electrical systems to enhance reliability. Fourthly, size conductors per NEC 310.15 to handle at least 125% of the motor's full load current, accounting for voltage drop and inrush current, and using appropriate raceways like rigid metal conduit or electrical metallic tubing. Fifthly, ensure a reliable power source, potentially including a generator with an automatic transfer switch compliant with NEC 700 to maintain operation during utility outages, with transfer occurring within the time frame specified in NEC 695.7. Sixthly, use a listed fire pump controller compliant with NEC 695.6, equipped with automatic and manual start functions, pressure sensing, and alarm contacts for remote monitoring. Seventh, be aware of the adjustment and correction factors for conductor ampacity based on ambient temperature and the number of conductors in a raceway, as detailed in NEC 310.15b, TUR and NEC 310.15c1. Eighth, consult with qualified electricians or engineers for assistance in determining locked rotor currents and selecting appropriate OCP sizes, especially when manufacturer's data is unavailable. Ninth, remember that overcurrent protection must not exceed the maximum size allowed by NEC section 430.52, which covers motor circuit protection. 10th, consult local authorities for any additional requirements or amendments to the NEC specific to your jurisdiction. Remember to prioritize life safety by following the NEC.